Hi Flat Earthers, this is Zach.
And this is Steve. In the previous video, we gave you an introduction on how the refraction in the atmosphere, or the atmosplane, was the solution to the various visual problems that were not working on flat Earth models. If you haven't watched that video yet, click on this link to watch it now.
Today we're going to explain a little bit more by showing you the star trails from different locations on the flat Earth. Many people thought that the video we showed before was not enough to prove that refraction is the reason why the sun rises and sets, and many others thought that refraction would make the apparent sun appear higher up instead of down. So to make this clear, let me tell you that what we did was add the atmosphere to the flat Earth model in Cinema 4D. And Cinema 4D made the apparent sun go down, not us. So if there is anything wrong with this, then it will be Cinema 4D's fault. If you disagree with the software, please send them an email and see what they will tell you. Now picture the sun is above you and the last layer of the atmosphere or atmosplane is a lot closer to you than the sun. The refraction will happen until the last layer of the atmosplane, which goes to the ground, right? So looking at the sun from the ground through the atmosplane can make the apparent sun appear lower instead of higher. And if you look at it this way, the apparent sun will appear higher, right? But this is all incorrect. What you will see from the ground is the apparent sun only. So whether it appears here or there, it is always lower, and the real sun is always higher. Now the question is, what makes the sun go down as it moves away from you? There are a few theories about this, but they can all be wrong. But let us explain one theory. If the atmosplane is only 5 miles up, and the apparent sun is right above it, then yes, perspective can make the sun go down in less than 7,000 miles away from the observer. And this will make the flat Earth model work. But you and I believe that the atmosplane or atmosphere is a lot thicker than that, therefore perspective will help a little, but not a lot. So if the real sun moves to the west for about 4,000 miles, how would the apparent sun look like from the observer's perspective? We can guess, but we will not know until we make a physical experiment that represents all of this. For example, we can do this in a big swimming pool to see how a refracted bulb will look like from far away, in order to see both refraction and perspective in action. If you guys can help, please contact us and let's prove this scientifically. But for now, let's just call it a theory. Because we're just trying to prove it in a 3D program. I'm pretty sure we are correct, but let's just call it a theory. Here is how the real sun and the apparent sun move in Cinema 4D. It's acting exactly how we expected. The apparent sun appears to move faster than the real sun. Therefore, it disappears in less than 7,000 miles away from the observer.
When the apparent sun is at 0 degrees, the real sun is at 35 degrees. And as the real sun rises at its normal speed, the apparent sun follows at a higher speed. The more they rise, the closer they get, and when they are 90 degrees, the refraction is 0.
This is a diagram I made in AutoCAD with the real elevation angles of the sun that we get from suncalc.org. This is the location and dates that I used. You can try that yourself. So when we draw the angles accurately, we notice that the sun travels faster the more it moves away from the observer. As you can see, the distance between 5 and 6 p.m. is a lot longer than the distance between 4 and 5 p.m. And the distance between 12 and 1 p.m. is very close to the speed of the sun on the Tropic of Cancer. On the globe model, you can say it's the speed of the spinning Earth in the Tropic of Cancer. But of course, the apparent sun doesn't travel in a straight line like the real sun does. So the distance between each hour should not be so exaggerated. We can draw it like this, but this is nothing but a diagram. And by the way, if perspective is the reason why the sun sets on the flat Earth, then the more the sun moves away from us, the slower it should appear to us, right? Imagine yourself in the middle of a highway. The cars that pass by you will be moving in their real speed. But as they move away from you, they look like they are slowing down. But that doesn't happen with the sun, right? In fact, the sun appears to travel faster the more it moves away from you. So perspective is definitely not the only reason why the sun goes down.
Here is how the star field would look if we removed the atmosphere. The place is Canary Islands, Spain. The lens that I used here has a 122-degree field of view, and as you can see, the stars never set because they are too high for perspective to make them rise or set. Their altitude now is about 4,000 miles. This number is fairly accurate and matches the rise and set times shown in the programs such as Stellarium. Now I am going to play the same video, but with the atmosphere or atmosphere added. As you can see, the video has changed completely and the star trails look exactly like the original picture. Here is the original taken on March 15, 2015. Now let's play the two videos side by side so you can see the effect of the atmosphere. We can do this from any location. They all work the same. And here is another test in France. Look at it carefully and compare it with the original, and let us know if we're doing anything wrong. And here is how the sun rises and sets in Salinas, California. We still need to make adjustments to the height of everything, but the atmosphere already makes them rise and set correctly. The atmosphere was the key to solving the puzzle.
This is a quick view of the stars in AutoCAD so you can understand how we drew them in Cinema 4D. All the stars you see on the model are 4,000 miles up, and the angles of the stars are accurate and they match modern science. We didn't make them up. And that Excel sheet on the left side of the screen shows all the data that we used. You can find it in the description. Here is a south view of the stars on the flat Earth with the atmosphere added. Now this should be enough for some trolls to see that wherever we are on the flat Earth, the sun and the stars will rise and set. And if they don't look like real life, then please try to understand that by adjusting the map and the height of all the objects in the sky can fix the problem. We still don't know for sure the heights of everything, and we still don't know for sure how the real map looks like. The point is that the atmosphere or atmosphere makes everything in the sky rise and set in Cinema 4D. If you think that the atmosphere should make things go up instead of down, then please talk to Cinema 4D programmers.
Here is something that we're going to talk about in the next video. When the atmosphere was added, the first thing that we noticed was that spheres looked oblong when viewed through the refraction. The only way to overcome this was to make the spheres as flat as possible. For the moon, it could not be perfectly flat, or the phases would not work. So the moon is a very flat sphere, or almost flat, but not 100%. Don't forget to subscribe to my channel, Steve Torrance, where you will find complete versions of the clips shown. I will also be doing more videos this week showing views from various locations. Thanks for watching.